Coming to the linked list, yeah. So linked is a default. It's a default class in Java. We just created this linked list methods, and we'll be studying it now. And it can be used as list, stack, and queue. Okay, and it is faster because we don't need any shifting in this. In array list, for example, if you add any element in a list, okay, so shifting is required. Okay, here what happens is there are two nodes. This node contains the data, and this is the next node. So if in a array list, if you add something here, the elements will have to be shifted to the right or to the left. Okay, I mean it has to be shifted on the right. Okay, because it would increase the array list length. In this case, linked list length, what happens is if I am adding an element of the 0 1 first index, so this node, next node of this, would point to the data of this, and this connection would be cut, which was initial, and this next node would point to the next data. So this is quite fast. Okay, the performance is quite good, and it allows the null entry, and it's not synchronized. So uh, it's not threads safe also. Multiple threads can access, read and write. Okay, so it's a dynamic correction, hence uh, insertion and deletion can be easily implemented. Okay, as we discussed about this also, it's pretty fast, and it can contain duplicate elements as well. Okay, so there are two kind of this constructors available: linked list and linked list. Okay, uh, collection also it can have. Okay, so okay, so now let's discuss about it, the implementation we have seen. So for example, if we have this small linked list, this is the generic names new linked list. Okay, so we have to import this java.util.linkedList also. Okay, over here, and here we can see I'll just comment this out. Okay, so I have just created one value. In this we only add values. Okay, data, as we said in the diagram above, that we store data, and it has two nodes, and one has data, one has next. So this node is connected to the head, and the last node is connected to the null value. Okay, so here we can see we have added two values. Okay, this one and this one. This is another value, second value. Okay, so names dot, if we try to print names dot size, we would get 2 in response. Okay, let's wait, we got 2. Okay, so now coming to this implementation, so here also see Tom is added. Okay, so this has this linked list has, we are seeing it in debug mode. So this Tom is the first element, so it has an ID, and next is pointing to null. Okay, and then the last element is this, and its next is also pointing to null. Got it? So okay, it's something like that. Okay, so here I think it would be more clear. Yeah, so here we have Tom, Naveen, Robbie, Lisa. Okay, so what happens is so if Tom in a doubly linked list, what happens is that it has three values. This is the previous, this is next, and then this next element, which is Naveen. Naveen is connected to this. Okay, and this is previous, this next is connected to previous, and previous is referring to next, and this next is pointing to null. Okay, now if we want to get an element, we would try to, as I've done here, if I want to get a first element, okay, get 0, it would print the null. Okay, we'll try. It will first print the names, which is these two values. Okay, and then it would fetch me the 0th value, which is Prashant. Okay, see, it printed the first value, and then now we create an iterator. Okay, so what we do is we write names.iterator. It returns an iterator. It returns a iterator. We can see here. returns an iterator over there. So we'll store it in an iterator. Okay, it string values are there, so it is equal to, okay, now while it has next, okay, iterator has next value, it would print the next value. Okay, and until it has the next value, it will keep on printing that. So with this way we can print the all the linked list values. So here two values should be printed, Prashant and is a great guy. Okay, so here Prashant had been already printed, so this is original and this is the new one, Prashant and is a great. Okay, so now is so we want to add value in this value, this 0 1 index, second index, if you want to add like this. Okay, so this will add it in the value, and it would, if you try to print it, it would now print three values, 0 1 and 2. Okay, so name would get added to this list. Okay, and we can see that it got added at the last. Okay, it got added. This can also be implemented using add last function, so that also can be done. If I try to get some value which is out of, if I try to get 2 over here, yeah, 3, okay, it will give me index out of bounds exception. Okay, why? Because this index, there's no value at this index, so we will get index out of bounds exception. Okay, so let's keep it at that, and then I'm creating new string, okay, with 3 names, users, and now if I try to add in the names, okay, this is being added in this list, above list. Okay, and what I'm doing is names.add, at first would add it to starting of the list. Okay, for Prashant, before Prashant it would come. Ghana, it would come, is a great guy, Ghana would come at the add last. Okay, and names.add all. Add all means this, all the linked list will be added to this one. Okay, the first one. So if we try to print out this would have these values, these two values, these two values, and also Ashish, Rahul, and Raghav. Approximately 8, I think. Okay, 1 2 3 4 5 6 7, yeah, 8. Okay, so I think, yeah, so and then add all is done, remove all. After removing all, it would remove these 3 values, so again we'll come back to 5 values. Okay, let's see if that comes. Now linked list lang is equal to new lang, so okay, lang is equal to new string, and then we have third index, so now you can see that 3 values got removed, 1 2 3. Okay, and then we have another collection, another linked list, and what we are trying to do is, here is print is reversibly, so we'll save this lang dot descending iterator. Okay, and save it again. This returns an iterator, over the elements in this DQ and in this DQ and reverse sequence. Okay, this DQ, okay, this is part of the DQ interface. Okay, so ss dot has next, if while if it has a next value, it will print that. So now if we try to print it, we see that these 3 values in reverse order would be printed: C++, Python, and Java. Okay, and for the last part, almost the last part, we want to print all the values in this linked list. So what I'll do is string e and try to print e. So it would print Java, Python, and after Java it will be Java, Python, and C++. Okay, now if you want to start, okay, sort it. So what we'll do, collection dot sort, and after it has sorted the linked list, if we try to print it, it would print it in the ascending manner. Okay, we can see that Python P came first, no, wait, so, yeah, so C++ came, C is first, and Java, and P is last, Python. Okay, so this is how we do it. Okay, so yes, that's it for this video, and I don't think so there's anything extra that I missed out. So this I already told you that shifting is fast. Okay, this because these, this one points to this and this one points to this, and this connection gets broken, so in this shifting is not required. Okay, so if you are trying to add anything here, okay, the where we are adding in at the index, what happens is this connection gets broken and the new index comes here, new node comes here, and this gets connected to that, and that comes connected to this. Okay, so for example, these two nodes are there, and these two, if we have 10, 20, 30 values, so data is stored in the first node, and the second one, it next refers to the next value. Okay, next always refers to the data of the last value. Okay, and I think we are pretty much done here. We've covered all these flows. Okay, so that's it for this video. See you next time.